doing problem 7 from practice exam 2. So we're given a parametrically defined function, equations. We're asked to find the equation of the slope of the tangent line when t is equal to -1. So we just have to remember our formula for finding the derivative dy dx for a parametrically defined function. So that's the formula, dy dt over dx dt. We've got dx dt, that's the derivative of this thing with respect to time, or t. This is the derivative of y with respect to t. So just plug that in, we're just going to get dy dx then is equal to the dy dt, which was 2 minus 2t. Divide that by the dx dt, 3t squared plus 6. And specifically, we want to know dy dx when x is equal to, or sorry, when t is equal to -1. Let me fix that. T is equal to -1. Okay, so just plug in your value for t there, and that's it. So 2 minus 2 times -1 divided by 3 times -1 squared plus 6. That's going to be 2 plus 2, that's 4. And 3 plus 6 is 9, so 4 over 9, which I believe is the answer that we got on that one. So just remember what this is telling us. If I could change this parametrically defined function into just a normally defined function, I would have to solve one of these things for t. Neither of them is going to be very easy to do that. But if I could solve one of them for t and then plug it into the other one, then I would have a normal Cartesian defined function. Okay, that function would match the parametrically defined function without the parameter in it. Okay, whatever graph we would have gotten, then what we're looking for is what is the slope of the tangent line when t is equal to -1, and then when t is -1, you can find the corresponding x and y value, so you could get an exact point on the graph to see exactly what tangent line you're talking about. Okay, so I might suggest that you go ahead and just graph this thing and you graph that thing, and then just notice that when t is equal to -1, you can kind of hopefully maybe at least see that the slope is going to be at least positive. You can see that it's going to be 4/9. That's what the answer that we got here was.